Power lines are so familiar you've stopped noticing how absolutely insane they are. Think about it. A wire, carrying 100,000 volts of alternating current, strung between wooden poles with no insulation on the outside. And birds, small, hollow-boned, fragile birds, land on them, sit there, groom themselves, fall asleep, and nothing happens. How? How is that possible? Here's what will frustrate you. The answer most people give is wrong. Not incomplete, not simplified, wrong. Birds don't survive because of rubber feet. They don't survive because the voltage is low. Some of those lines run at voltages that would kill you before your brain could register the pain. The truth is something Tesla tried to explain to a world that wasn't ready to hear it. Electricity doesn't behave the way you think it does. And once you understand what it actually wants, what it's actually doing, the bird stops being the mystery entirely. Let me show you what I mean. Birds have dry, scaly feet that don't conduct electricity well, or the voltage isn't high enough, or their small bodies don't provide a good path for current to flow. You might have heard one of those. They're not entirely wrong, but they're missing the point so completely it's almost embarrassing. Because here's what none of those explanations tell you. Some of those birds are sitting at 100,000 volts, more than some of them, and dry feet don't save you from 100,000 volts. Nothing about the bird saves it. What saves it is something hiding inside the nature of electricity itself. Something that Tesla understood at a level most engineers today still gloss over. Voltage isn't what you think it is, and once you understand what voltage actually means, what it actually requires to be dangerous, the bird becomes the least interesting part of the story. Start with something simple. Picture a river, not a metaphor yet, an actual river. Water moving from high ground to low ground, from the mountains down to the sea. Now ask yourself, what makes the water move? The difference in height. That's it. Water at the top of a mountain isn't dangerous because it's water. It's dangerous because there's somewhere lower for it to go. Give it a path downhill and it moves, fast, powerfully, destructively. Block that path completely, and the water just sits there, perfectly still, perfectly harmless, even if it's sitting at the top of a 1,000-foot cliff. Height without a drop is just scenery. Now stop thinking about water, because electricity works the same way, not as a metaphor, as a physical fact. What moves electricity isn't voltage, not exactly. What moves electricity is the difference in voltage between 2 points, a high point and a low point. Just like the river needs high ground and low ground, electricity needs high voltage and low voltage, connected by a path. Without that difference, nothing moves. That's the thing Tesla grasped that changed everything. Voltage alone is meaningless. Voltage is just a number describing where you are. What matters, the only thing that has ever mattered, is the gap between where you are and somewhere else. And now look back up at that bird. That bird is sitting on a wire at 100,000 volts. Let that number land. 100,000 volts. For context, the outlet in your wall runs at 120 volts. Enough to kill you if you touch it wrong. This wire carries more than 800 times that, and the bird sits there, calm, unbothered, occasionally preening its feathers. Here's the first thing you need to understand. Voltage is not a force. Voltage is not a current. Voltage is not something that flows through you and kills you. Voltage is a position. Think back to the river. A rock sitting at the top of a waterfall isn't being crushed by the height. It's just up there. The height only becomes dangerous when there's a path down, when something connects the high point to the low point. The bird on the wire is like that rock. It's at a high position, 100,000 volts relative to the ground far below, but its feet are touching one wire at one voltage. Its entire body, feet, legs, chest, wings, beak, is sitting at exactly the same voltage. Every part of the bird is at 100,000 volts, which means the difference in voltage across the bird's body is zero. 0 volts of difference. 0 push, 0 flow. The electricity has no reason to move through the bird because there's nowhere for it to go that's any different from where it already is. But wait, if that's true, if voltage difference is what matters, then what happens when that difference exists? Here's where it gets precise. Current, the thing that actually moves through wires, through bodies, through anything, doesn't care about voltage. It cares about voltage difference, the gradient, the gap between high and low. Electricians have a word for this. They call it potential difference. And Tesla understood potential difference not as a technical term, but as a fundamental description of reality. Difference is what drives everything. Sameness drives nothing. Now here's what should bother you. If a bird touches two wires at different voltages simultaneously, 1 foot on a 100,000-volt line, 1 foot on a grounded wire, suddenly there's a difference. Suddenly there's a gap. Suddenly electricity has somewhere to go. Through the bird. That's not a theory. That's exactly what happens. The bird becomes the path the current was waiting for, and it takes less than a second. This is why power line workers are so meticulous about something called equipotential bonding. Before they touch a live wire, they make sure every conductive surface around them, their tools, their platform, their suits, is brought to the same voltage as the wire, not 0 volts, the same voltage as the wire they're touching. They make themselves into the bird. Same voltage everywhere, no difference, no current, no danger. Think about what that means. A trained electrician can touch a live 100,000-volt wire and survive, not by avoiding the voltage, but by matching it, by eliminating the difference entirely. The danger was never the voltage. The danger was always the gap. But that's still not the full story, because if voltage difference is what drives current, if the gap is what matters, then what exactly is voltage? What is this position we keep talking about? Now we're at the core. Voltage is potential energy stored in an electric field. It's not a substance. It's not a fluid. It's the electrical equivalent of height, a measurement of how much energy a charged particle would release if it moved from here to somewhere else. The key word is would. Potential energy is energy waiting for permission. Water at the top of a cliff has gravitational potential energy. It doesn't release that energy until it falls, and it can only fall if there's a path down. A charged particle at high voltage has electrical potential energy. It doesn't release that energy until it moves, and it can only move if there's a conducting path to somewhere at lower voltage. The bird provides no such path. Its body connects one point on the wire to another point on the same wire, at the same voltage. There's no lower place to go. The electrical potential energy inside the wire looks at the bird and sees no opportunity. This is what Tesla tried to explain to a world obsessed with whether things conducted electricity. The question was never about conductivity. Copper conducts, rubber doesn't. The bird's feet are somewhere in between, but none of that matters. What matters is the geometry of the situation, the topology, where the high voltage is, where the low voltage is, whether a path exists between them. The bird isn't safe because it's a bad conductor. The bird is safe because it's a closed door on an empty hallway. There's nothing on the other side. And once you understand that, once you see what voltage actually is and what it actually requires, you realize something that should genuinely unsettle you about your own assumptions. In your normal experience of the world, high voltage means danger. That's the rule. That's what you were taught. Stay away from power lines. Don't touch exposed wires. High voltage kills. It feels obvious. It feels undeniable. It's incomplete in a way that matters enormously. Pause. High voltage doesn't kill you. Voltage difference kills you. Those are not the same thing. They have never been the same thing. And confusing them is exactly the mistake that makes the bird on the wire seem like a mystery when it isn't one at all. Let me prove it to you. Van de Graaff generators, the metal spheres you've seen in science classrooms that make hair stand up, can charge a person to 100,000 volts. Scientists and teachers do this routinely. The person stands on an insulating platform, touches the sphere, and their entire body rises to 100,000 volts. And nothing happens. No pain, no current, no danger. Because their entire body is at the same voltage. There's no difference, no gap, no path from high to low. 100,000 volts, completely harmless. Now touch a grounded surface while you're standing on that platform. Connect. Connect the high voltage to the low voltage. Create the difference. That's a completely different situation. Think about what this means. A bird at 100,000 volts above the ground is not in danger. A bird touching two wires at different voltages is dead before it registers what happened. The voltage number on the wire is almost irrelevant. What matters, the only thing that has ever mattered, is whether a difference exists and whether a path exists to exploit it. The bird isn't safe because it doesn't conduct. The bird is safe because there's nowhere for current to go. Voltage without difference is like height without a cliff. Present, measurable, completely harmless. That's not a metaphor. That's the actual structure of how electricity works. Tested, measured, proven to decimal places Tesla himself would have appreciated. And once you see it, once you really see it, you realize this principle isn't hiding just in power lines. Now here's what people miss when they learn just about birds and power lines. This principle, voltage difference, potential gradient, the gap between high and low, isn't isolated to electricity. It's a pattern woven into the fabric of reality itself. The same principle that keeps the bird alive also explains Why water doesn't spontaneously flow uphill, no pressure difference. Why heat doesn't flow from cold objects to hot ones, no temperature difference. Why chemicals don't react when they're already at equilibrium, no concentration difference. Why batteries die. They've exhausted their voltage difference. Their high and low have equalized what looks like four completely different phenomena. Electricity, fluid dynamics, thermodynamics, chemistry, is actually one thing manifesting in different forms. Difference drives flow. Sameness drives nothing. That's not a philosophical statement, that's physics. Energy moves down gradients, always, from high to low, from ordered to disordered, from difference toward sameness, and you're not separate from this. Right now, inside your body, your neurons are maintaining voltage differences across their cell membranes. 70 millivolts of difference, tiny compared to the power line, but enough. Enough to fire signals, enough to move ions, enough to create thought. When that difference collapses, when the gradient disappears, the neuron stops working, the signal stops, the thought ends. You are made of controlled differences, voltage gradients, chemical gradients, pressure gradients. Your entire existence depends on maintaining gaps that want to close. Life is the temporary resistance to equilibrium. That's not mystical, that's magnificent. That's what Tesla saw when he looked at electricity. Not a utility, but a window into how everything flows, everything moves, everything happens. So when you see that bird on the wire next time, don't just see a bird that isn't dying. See an example of the fundamental law that governs everything from your neurons to the stars. So why do birds sit on power lines without dying? Because they're at the same voltage everywhere across their bodies. No difference, no gradient, no reason for current to flow. The bird could be at 100,000 volts relative to the ground. It doesn't matter. What matters is that it's at 100,000 volts relative to itself, which is to say, zero. The bird isn't protected by rubber feet or poor conductivity or low voltage. The bird is protected by geometry, by topology, by the absence of a path from high to low. But understanding this isn't just about birds. It's about how we think about danger, about electricity, about the invisible forces that surround us constantly. A century ago, Tesla stood in his laboratory and let 1,000,000 volts of electricity dance across his body. Not because he was reckless, because he understood what voltage was. He understood the difference between position and flow, between potential and current, between where you are and where the energy can go. The world thought he was performing magic. He was demonstrating physics. The fact that we can understand this, that we can measure voltage to 11 decimal places, that we can touch live wires safely when we know the geometry, that we can explain why a sparrow survives what would kill us if we made one wrong step. That's not trivial. That's the triumph of human intelligence over mystery. The universe follows rules. Precise, testable, beautiful rules. And we figured them out. Not all of them. We're still learning. Still discovering what else hides in the gradients, in the differences, in the spaces between high and low. But this one we know. That's what electricity really is, not a fluid that flows through wires. A difference seeking equilibrium, not comfort, not simplicity, truth.